Hi everyone, this time we are going to build the pipeline itself, and our goal to build the pipeline like this. It has the following steps. Reading step, which is going to read the inputs from BigQuery. Prediction step, which will do the inference. And writing step will write the output back to BigQuery. And we have one more step over here, temporary root step. And the reason we need it is because each individual step runs in a separate pod, so they don't share memory, but they have to exchange information somehow. For these purposes, we'll create a subdirectory in a storage bucket, and each of the steps can write this information to the bucket or read it from. So it's going to be like this. And the timestamp. Now let's go through source code of the components. And the first one is reading step. First we initialize the BigQuery client, and we open the SQL query that is saved as a file, so we don't embed it in a Python module. Execute the query, and we write the output here. Prediction step uses OrientExpress library. We initialize the model wrapper, load the input from the previous step, and we run the inference. And the output is saved in the predicted.parquet file. And the last step, we load this predicted data frame, initialize a BigQuery client, write this table using this helper function. Now let's review what we have. So we defined the source code for our components. We also built a push Docker image. Then we need to create a pipeline DSL file that defines the components and relationship between them. Then we are going to use Vertex AI compiler to compile the DSL file into pipeline YAML. Now let's take a look into pipeline DSL definition. The pipeline.py file contains functions that are decorated with a special DSL component decorator. So this is our function, and this is the decorator. Decorator can take some configuration parameters. For example, in our case, it is a Docker image that we built before. The function itself contains the code that we want to execute. And please take into account that we have to put imports inside the function, because what compiler will do, it will take the function body and put it in a separate file internally that will be run in a Docker container, which is in a pod in Kubernetes and stuff. If you don't include it there, but include it like a normal Python file, like somewhere on top of the file, the import won't be included at all. So please keep it in mind. This specific function, temporary root, it will create a temporary root variable and return the output that can be used by the other components. As we moved read, predict, and write step into separate files, here we only define how we import them and how we execute them. So the read component will take temporary root input parameter coming from the previous component, and we just execute the modules that we defined before. Now let's configure the pipeline main body, and it's a Python function which is decorated with dsl.pipeline decorator. Here we pass the pipeline name, description, and etc. The pipeline itself contains the definition of the components. The first one is temporary root. The second is a reading step. And we also pass temporary root, which is the output of this component, as input to reading step. The third one is a prediction step, and it also takes temporary root as input, but we also explicitly define reading step as a requirement before it can run. We didn't have to do that for reading step because when we specify the output from the previous component, it will automatically mark it as a dependency. And the last one is writing step. Again, we pass temporary root and we specify prediction step as a requirement. So this function is not a regular Python function, it's a DSL. It will be read by the compiler. It will check what steps are used there, relations between them. And it means that like regular Python expression won't work here. So if you want to concatenate strings or use, let's say, if-else operator, you have to use special objects from SDK. So if you just write if-else, it won't work. It will be processed by the compiler, it will execute something, but in runtime it will be ignored. Now we can run our deployment script to run the pipeline once or to create a scheduler. Of course, we need to authenticate using gcloud first, and this command will pop up the authentication dialog asking for permission and stuff, but then the script will work and do the job. And here is our pipeline. This is the image from the beginning, but this is a real screenshot from Vertex AI. This is how in the console we see the scheduler. Here is the list of schedulers, and this is the scheduler with the attached runs. So if we click any of those runs, we open the run from the previous image. This is it. If you have any questions, you can write in the Discord channel, which is in the video description below. Thanks for your attention. Bye.